I'm going to talk about getting work done with APL, because I use it every day, not just as a hobby, but I actually do it to do data analysis and ad hoc queries on data, manipulation, and full stack application development. So that's something that some people who are new to APL have never seen. So with this APL seeds that we're doing, I like the imagery here because we have seeds. So hopefully in this talk, we'll take a look at what does it look like when your seeds come to fruition. Is it worth the investment of spending time to learn this language? Well, what are some of the things I could do with it? So hopefully we're going to look at 3 problems here and look at what you can do with APL from that perspective. And then I just also thought with this allegory of seeds, what do they need to thrive? Soil, water, light. So this concept of soil is kind of, it needs a good ecosystem. It needs to interact well with the ecosystem. And that's what a lot of the Dyalog interpreter has been focused on. If we look at what the goal of an APL interpreter is, I think it's to boil a problem down into simple arrays. So you have the Iverson toolkit exposed, which has largely been the same for half a century. There's been work, but a lot of the stuff has been with interfacing with files or databases and other environmental things you would need to get your work done. So one thing we'll start with is we'll look at some system functions for file reading and writing. I know there were questions on what is this quad symbol. So yeah, this quad symbol alone, as you said, can be used to reference input and output, but quad as a prefix means it's a system function. So these are, general, they're not related to the core of the language, but they're just generally utilities used that make your job easier, but they operate just like a regular APL function or operator, or they could be variables or a reference. So some ones you should know or be aware of are this quad N read and quad F read. This is for native file reading, so reading any type of text file or any type of file on your operating system, you can read it in with quad N read, and then there's more options to control specifics on that. When you see quad F read, this is referring to component files. These are native. This is a Dyalog way of representing arrays, or you can have a complex nested array and push it out to a text DCF file using these quad F functions. And there's read, there's and a whole host of different functions. If you just type in quad N in the session, you'll see the autocomplete fill this out. And then some of the more practical more universal ones we have here are for CSV, XML, JSON, and quad map lets you memory map of an array to disk and work with it. So this is really good if you're dealing with large data sets. You can work with this. And these are for exporting, and you can also do imports with these. So we can take a look at one of the Kaggle has a lot of example data files. So one of the top rated CSV files was this water potability file. So we could start by taking a look at this. And I figured with all the train derailments and water spills here in the States, it's probably a good thing to be aware of to see, is your water potable, or is it good, fit to drink, safe for human consumption? So we have this file, and in it gives us a list of different property values for contaminants or other chemical properties. So you don't need to read this in detail. This is just for information to know what we're looking at. We will now go to an APL interpreter and take a look at this. Okay, let's launch APL and hide this. I'll increase this font size a bit. So I'm assuming this is okay to read? If not, let me know. So how do I have the CSV file out over here, and it's called water potability.csv. How do I bring this into the APL session? Well, it's as simple as just quad CSV. So we've read in 3,000 records, 10 columns. I could turn boxing on, take a look at 5 of them. So this is what we have. We have all this data, headers and data. And one thing you'll notice, what you want to do is quad DR tells you what the data type is, and each is an operator which applies to each cell. Yeah, so if I do this, you'll see 80. And what the heck is 80? You don't need to memorize this. Whenever you put your cursor to the right of something in APL, you could press F1, and this launches the help. So monadic, this tells us what the data type is. So there's different values for different. So we saw 80s, which means these are all character. And if we want to do analysis on this, we don't want this as character. We want this actually as numeric. And so you could scroll up and just change this. If you look at the CSV documentation, there's an option here to specify to cast to numeric values if it can. So we run this again, 645, which in the documentation states this is 64 bits floating point, which is good. We want that. And one thing we want to do when we do our analysis is we need to get rid of, it's good to separate the headers from the data so we have everything of the same type. So very simple, we saw take, so headers there, data will drop, we'll do one drop. So now we have our data, we're going to work with this. And before we do analysis on this, we see a lot of empty cells here. And it's good to, if we don't have data points for something, we should exclude it before so we don't want to look at it. So the shape of D, right now we have about 3,000 records. So how do we get rid of empties? Well, we could take the shape of it, and there's you'll see this is in green. This means this is an idiom in Dyalog APL, which means it's optimized C code to perform quickly. That's when you see it. It might be different based on your color theme, but this is what it would look like. So I could say, is 0 a member of the shape of each? Because, I mean, if we did the shape of each, you could see. So when we look for empties, we want to do this. And this gives us a Boolean mask of, yes, this is empty, this is empty, this is empty. So if we want to exclude all rows where there's a single empty element, all we do is we could do the OR row across the rows here. So this is the reduction we've seen before. So this says, it gives us a Boolean vector of ones where there's an empty, and then we could toggle. So these are the ones we want to keep. So we can take this and compress the entire D data set, and we'll just call this no empties. And now this is down to 2,000. So we've cut about a third of the records off. So now we look at the first 5 rows, and we have just values. So now, because we have this, and this is 2,000, we could just do a very quick analysis. What's the max of each column? And it's that simple. We could, and the min likewise. And we remember, here are the headers. So the first one is the pH. So this is saying that there's some water with a pH of 14 and which is insanely high, because from a limit table we have, we know it should be between 6.5 to 8.5, the pH. So this is kind of concerning. Now the last column here is a Boolean potability. Is it safe to drink or not? So let's take a look at records that are marked as safe to drink, and then we'll perform the same analysis. So we have this, and the last column. So we looked at, you've seen plus being used, this function with an operator, this reduce operator, which says put plus between everything. We could do this on the rows. Likewise, we could replace this with any function. So multiplication, and because the last column is 0, this returns 0. So an interesting way of getting the last column is this identity, this right symbol, which says, give me the right argument. So if we were to imagine putting this symbol between every single cell here, it's just going to keep going to the right, which is kind of a neat way of getting the last column. And likewise, you could do that to get the firstmost. And there's other ways to get this too. You know, you could do the -1 take to get the last row, and then you could use the access operator to specify I want the last column. But we'll just use this, and we don't want to. What we want to do is to get the last column and then use this as another mask. So using this to filter out records which are marked safe to drink. Before we do that, it's good to take a look. Let's do a plus. Oops, not on this. And if you ever type something that's too much, right-clicking and interrupting is something you should learn to have handy. So if we take a look at the last column again, and what we want to do is say, what's the sum? How many? So there's 811 records that are marked safe to drink. So we want those. And let's take this and filter this by it. And we'll just call this P for now. And now, yep, we have 811. And here we go. So these are all records that have been marked safe to drink. So again, we could take our max and min, and of this P, oops, right. And then this tells us, we could see that which ones are within the range or not within the range. And you could see that one is the max and min, which also is one way of making sure that we only have values of 1. So our question is, do we have any records that satisfy? We have limits for each one of these columns. So I have another file. Let's bring that in and do a comparison to see what other files, what other records are potable, and check how well their classification is versus our own. So we could take a look at this water limits. I have a JSON file here. And remember, quad n get is how you can just get any file. So if we want to look at the contents of this, we take the first result, and now we have our limits, and we have upper and lower limits for every property here. And quad JSON, as you've seen before, translate this into a namespace. So this is how we represent objects. And limits here, this is actually an array of objects, array of namespaces. We can call this O. And then we could just dot in and say, what's the upper limit? And what's the lower limit? Let's assign this to U and lower limit as L. So now we have this, and we have P. And let's get rid of the last column of P. So we'll just do a 9 take. You could use the access operator here to do this, or rank operator, or just simply indexing, which is probably more familiar to most of you. We want to get the first 9 columns, and we'll assign this here. Okay. So what we're going to do now is, let's just take a look at one of the rows. Let's take a look at the first row here. And we want to say, is this within the limits? And this is set up to be 9 columns, and our lower limits are a vector of length 9 as well. So if we want to see if everything's greater than the lower limit, it's that simple. We could do is this greater than this? And this does a, remember, we don't need to write a loop to do this. It just goes ahead and maps each item because we have the length down similar. And then similarly, we could see where everything is less than the upper limit. And here there's less results. Only 3 match the criteria. So if we wanted to see, let's try this on more than one column. If we do 1, 2, this is not going to work because the rank, we need to specify which rank we want to do the comparison on, which is why it's good that we saw the rank operator, because we could change this to simply say, do this on the rank 1 of the left and right argument. And there, this takes care of it for us. And when you use operators, any type of rank thing, a good thing to learn is you could put any function here. So just put your own function that returns the left and right argument to kind of see what it's going to do. So this says, okay, I'm going to get past this as alpha and this as omega, which is the left and right argument. And versus and this is short for this. What happens if I put a 0 here? You could see that it gets grouped differently. Control-Shift back is how you bring up the last item you typed as well. That's helpful to know. So anyways, that's just the aside there. So the function we're looking at, we want to use is this less than. Okay. And then, so we don't even need to, we want to do this on all of P, right? For now, what I'm going to do is make this a function, just an inline function here. So we can work on just 5 takes so we could see it. Because we don't just want the upper limits to match, we want it to be between the lower limit as well. So we could take a similar expression and replace the upper limit with the lower limit. And now we have 2 matrices, and what satisfies the condition if we AND this together. So here we go. Now we could see all those records which match both criteria, okay? And we could just do this on all of P. Well, let's stick with 5 for now. And we want to say it's a match if we AND all the rows together. So if every item in a row is 1, that means the water's safe to drink. And you could see with this, it's not. So let's get rid of the 5 take of P and do it on all 800 elements. And no, nothing. Wow, none of these are safe to drink. So, and these are all, remember, P is already filtered. The data set said that these are safe to drink. So we're just doing our own analysis and seeing that this data set is obviously bogus, because there's no way that these should be classified as safe to drink. They don't match criteria for what's the maximum we get, in fact. You could see the maximum is 6. So at best, we have a record that 1 or more records that match, that fill 6 of the 9 criteria for safe drinking water. So that begs the question then, if this random data set is probably just randomly generated, it's not actual data, are there any records in this data set? So we can look at our not empty data set. So we remove this filter and we'll apply this on the first 9 columns, okay? And we'll say, is there any? And we could sum that up, 0. So actually, there's nothing. And likewise here, oops, there's nothing. I forgot to put this in here. If we wanted to see what's the highest, it's still 6. So that shows us, we just did very quick. This is how you would probably do an analysis in APL. It's very ad hoc and you build the expression as you go. The session is great for this type of interactivity. And okay. Oops. So just to show this expression here, what this little statement did, the rank, it's actually the same thing Richard showed in his first presentation. But what we did essentially is we looped for each row of this matrix, for each item of this vector of limits, match them up and compare against its respective column. So this was a very simple way to do this, and then obviously ANDing them together. I'm sure there's probably another way you could make this more compact or golf this down, but this was good enough for me. So That's the solution we had. Okay, so that's CSV. And another example we could look at is XML. So here's a real problem I had. So someone asked me, they had this XML type file. It's called MZXML, and they were a researcher. They said, can I pull this in to APL? This is an XML file, and you'll notice here we have this peaks, which are this is from a mass spectrometer, which is an instrument that gives off the mass to charge ratio of ions. So this has data that we want to get at and do some analysis in APL with. So how do we get this? And if we blow this up a bit, how do we convert this into meaningful numbers? Well, if we look at the specification, this is actually done with base 64 decoding. So the algorithm for base 64 encoding and decoding is, if you have this string, MA, what you do is you take the ASCII, the code point here, the number, and then you convert this to 8 bits, the 77, and then you group this up into groups of 6 and evaluate that, base 2, and then with this number, you use this to index into character sets. And then basically this is how you get your encoding, and then to do the decoding, you just do the opposite. Okay, so this is what we have to do. So first we have to get the XML file, then we have to do some base 64 encoding, decoding. So let's look in APL again. Okay, we'll take a look. Oops. Sorry. So let's start with Clear Workspace, and let's look at, this is a project I did. When you start coding with APL, most people are familiar with workspaces, .dws files, but now you want to move to text files using link or something. Like me, I use Dado, which is a project management system. So this reads in files from disk. And it does a little more than link. I did a talk on this before if you're interested in it, or it's an open source APL repository. But here I have things, because this is a living Git repository on my file system. So I could see things like show any changes I've done, any branches I have, and I can look at a quick summary of my last commits, and could be from anyone because this is just a Git repository. So this is all built into the APL session, and me personally, I prefer having user commands that chain a bunch of Git functions together rather than doing them by hand. Also gives you things like, can I run my test and see what my code coverage is for my project? It could use some work. So this is still version 0 of this. Anyways, let's go to our main namespace where we have functions. And basically our function we want to do is, let's read one of these MZXML files. Well, we want to read the file and give it a path. So I have a file here, and Control Enter lets you trace into a function. So you could see this is my function. And some people ask, oh, how do I write APL in English? Well, this is how you do it. You just write very clearly defined function names, and you hide your APL code behind these names. So this read XML is just a wrapper for doing the quad XML on and get the file contents. So we put this in T, and just to show, sum of T, you could see quad XML returns this to us as a matrix here. And the specifics, you could look at the documentation, but basically this first column gives us, this is how we represent a hierarchy or a tree in APL. We could just use depth vector. And Aaron Sue's done talks on this, of how he uses this to do tree wrangling in APL, which is a nice talk. And you don't need to have this tree data structure that you see in other programming languages. So here we go. This is it. We could just get some basic info. R is a namespace, and it's good for storing, kind of like a dictionary of properties. Quad JSON is actually a good way also. If you give it a namespace, you could kind of take a peek at what is inside a namespace if if there's no functions, because JSON can't handle functions, it's just variables. And then in my, eventually I have a function called decode peaks. So let's put a breakpoint here and run this. We could breakpoint, or you could control enter. And if I run this, it's going to go into and stop here. So this is how we decode these peaks. So we have a base64 decode function, and let's of omega. Well, the right argument is this. This is what was in the XML file, easy to get. And then we run our base64, and this is our whole base64 decoding function. It's, I think, very simple, a few lines of code, and it very clearly represents the algorithm, what we're doing with the chunking, partitioning things, and then taking care of padding. No control structures or anything needed. So we do that, and we've done the decoding. We can convert this quad DR dyadically, lets us move data types, so we get the binary representation of this. This is 45,000 bits here. We resize this up into a Boolean matrix, and then for each row, we go ahead and do a binary to single, the IEEE conversion there. And all right, so we could just continue, and let me actually escape out of here and remove breakpoints. Zoom. Okay, so I remove that, and we can assign this. So the function was called read file. Okay, so we could assign the result of that, and we organized the results in a namespace here. So we have a peaks variable eventually, and there's a few scan objects here. We just did it on 5 scans. And let's take a look at the first peak variable. And that's just 705. So we have our numbers here. So there we go. This was an APL project to read from that XML file and do the conversion. And basically, we can go back to the PowerPoint. This was my solution here for encoding and decoding. Remember the algorithm from before. And also the competition winner did this problem, Zuxing Li. And here's his solution. And I also think it's quite beautiful. And the interesting thing is, look how easy it is to generalize this and apply a solution for base 85 as well, which can be more efficient way of encrypting the information, or encoding the information. So this is all the code it takes really to have a general solution in comparison to something like a Java solution. And these are from Rosetta Stone for this problem. Java solution, a VBA solution, which, people say, well, I want to write this in an English-like language. It's more readable. And to me, I would rather look at, 4 or 5 lines of APL than 40 lines of VBA, and it's too much for me to, absorb at once. And yeah, can you do it with one? Most languages have a library to do one call, .NET, base64 encode, decode. Yes, you could do that as well with APL. And that's what I originally did, but it's better to remove the dependency and just write a simple solution. Here's a JavaScript solution. Okay. So now let's take a look at some other things we could do with APL, which is database connectivity. So here's an example of LeetCode 185, which is ranked as a hard SQL problem to solve. And we want to get the department top 3 salaries. So if we have a table like up here, and there's name, salaries, and department IDs, we want to say group them by departments, and let's look at the top 3 salary earners for each department. And notice if you have duplicates, like for the IT department, the top 3 are 90, 85, and 70. There's 2 85s, so we get 2 records here. Sales only has 2 records, so we want to make sure to only return 2 records. So what we'll do is let's go to APL, Okay. Let's go back to the APL session. And actually from APL, it comes with its own SQL interface. So SQAPL. And here you have a whole namespace of functions. And there's a very nice documentation to explain all these functions and how to set up a connection and so on. But I'm not going to do this all by hand because I don't want to type in all the connection configurations and everything. So what I have is I have another project. We can open another project here called SQL Browser. It's a custom SQL browser written in APL to just do a cover for this. Because when you're writing queries, you want to see a list of the table names, the column names to help you come up with your query. So let me also come over here and start up some local databases I have. Okay, so services. And let's start this. So I'm starting up a database and I have this run function. This is also an open source project. If you're interested in how do I write a full stack or a GUI application, this might be an easy template. So here, what we're doing is we're trapping any error. We're just going to notify. Quad DM gives you the error message. Very simple. We're going to make the main form. And you'll see Quad WC programming talked about in APL. So this, I just created a form. And what I'm not going to make this visible. I could skip this line and keep running. So you can assign callbacks like on close, I'm going to run this function, which is my own custom function to make sure all the database connections opened are closed. And I'm going along here, and you could see me building the GUI in real time here. And this is a very simple one. And, so making the table explorer is an example. And here I say, whenever you double click in the tree view area, call this function. So for example, I could put a breakpoint here and we can close this to see what happens on events. I'm just going to continue with this. Okay. So here we go. This is our little, very simple GUI application, all written in APL. And so if I double click on this, you remember we have an event here. So this says we get a callback here. So we can have our APL functions handle events. So the interpreter, Dyalog APL interpreter, does a bit more than just the symbols. It handles all this type of front-end application development. So we could say what was selected. The index was the third item. That was the third item here. And we could say, does this index have children? Basically, like we saw with XML, is there a number after it that's greater than it, which means it was already double clicked and expanded. It has children, right? So 3. So this wasn't expanded yet. The depth is 0, so we know we double clicked on a database. So we go ahead and just do our connect. Okay. So this does the connection for us. And now we have a schema and table. So say we wanted to expand a table. We double click again and we're in the same callback. We can go through and the depth is now 2. So we know we're expanding a table. So we just go and we make the SQAPL call to get all the column names. All right, so here we go. This is our little SQL browser. We easily built an APL. But remember, we were doing a LeetCode problem. So let's go back to the problem here. And let's look at this. We have this employee table. Look at the columns here. We could do a select star from this. And these are all the records we have. So the top solution, one of the top solutions I found for this problem on LeetCode was this SQL query, which we can pull down here and look at. This is what it does. So we can run it, and here we go. And this, when I hit run, I'm making SQL calls through the APL, SQAPL library. It's just a very thin cover for that. And then populating this APL array. So here's the result. We have the top 3 salaries in the first department and the top 2 in the second. Okay. So this is a cover for SQL, doing SQL with APL, and it's a very nice integration. Used a lot, and it's quick. And you just pull tables back as APL arrays, and you could do whatever you want with them. So let's now take a look at something else. How do we solve the same problem with another app? This app is called FlipDB. It's by the Carlyle Group, and this app is completely written in APL. So it's more polished than this simple app I showed. So this is a APL front end and back end. It's called FlipDB. And Paul Mansour has a blog where he spoke about this LeetCode problem and presented a solution in FlipDB, which is the application we're looking at here. And it has an APL-based DSL. It's a domain-specific language. So we could do a lot of the same tricks we use in APL here. So what we'll do now is we'll create a new database in this application. We'll call it, we'll see, it's 23. This is empty. And we want to do this on, let's do some real data here. So we'll create a new import and run this. And we'll say we're going to bring this from a CSV file. We're familiar with those by now. So here's a CSV file of the New York City payroll data in 2020. And this front end is APL, and this too, you'll notice Quad CSV has other options. These are just these other options in Quad CSV, which is what this is a cover for. So let's pre-process this data, and so we could take a look at it and do any transformations before we put this in a table. So we have about a little over 500,000 records here. And okay, here we go. So we could see that we've gone ahead and we've done some casting on some of these columns, making sure that the dates are properly formatted. So here's our table. Looks good. We want to load this into our new target table. And we will put it in this table here. We'll call this table payroll. All right, so it's going to create this table. If we do an overview, yeah, we're going to about 600,000 rows. We're going to bring in. It looks good. Let's do an import. Create, yes, and done. So that was created. We imported those, and this is all running in an APL engine. So now we can come here and let's take a look at a quick dashboard of this. It's a more it's more complex than the simple LeetCode table that was provided. And this is interesting because this is actually HTML. We talked about Quad WC, that's a Win32, but this application now has a mix of HTML front end. So this is, if I look at the page source, actually, this application has HTML that's all generated from APL. There's a library called Abacus that generates this using things like Quad XML and creates a virtual DOM. So you can control the HTML engine from APL. Anyways, let's look at this table. And so what we'll do is we'll do the same query. We'll group this by, we'll take a look at their base salary, and we'll just group that by their agency names as departments. So let's insert a new query here. And this is a different thing than using SQL. Remember, this is an APL-based approach to SQL. And right, so we go to our query, and we can compute columns beforehand. So we'll make a new column called monthly salary, which is the base salary divided by 12. We could do a simple expression here. That looks good. And then what we could do is Zoom slows things down for me quite a bit, so apologize for that. And we could say our where statement is going to be, we have pay basis, and since we're doing it by salary, we want to make sure that this is consistent. So we'll say where it's yearly. We only want those records. And also then we have the solution, Paul's solution, which is where we take the 0, 1, 2, so the first three of the dense rank down by the monthly salary that we just created. And by is an operator, so we can have the power of operators here as well. This is a function, this is an operator, and we could group by agency name. So this is it. This is all we have this sort of array solution. We hit OK. And then one other thing we want to do is limit the amount of columns we're seeing. So let's just take a look at the department, as we could assign that as the agency name, and the monthly pay as monthly, monthly salary. Just call it that. Do this. And here, we've done this. Let's do a sort on it for good measure as well. We can do, we'll sort by department going up. Okay. So with that, we've basically, with one where statement, we've done for this department here, these are the top 3 respective salary, sorry, these 3 here. These are the top 3 salaries here. And then here we can also see some repeats, which is why we have more than 3 records. And the nice thing about this too is we also have the power to trace this query, because this is really like a list of defunds, which you can't really do in SQL browsers. Where we have this, we could trace and see what's going on. Right, so the division happened here. Keep going. Where statements, we could see what mask is being applied and how many we're losing after this. So this is quite, a powerful tool. That's all running APL behind the scenes, front end and back end. Okay, so there we go. That was tracing it. And also there's very good Excel interoperability with APL. So we could, if we need to generate reports for someone, we could do that very simply from within APL. We have several libraries. So I'm going to export this all across to Excel, and then we should get a report. One other thing, while Excel loads, one other quick example I just want to share as my last thing is, here's another example of, so this was the difference between the 2 things. Another LeetCode hard problem, which has a trivial APL/FlipDB solution, because if you look at this, if we want the frequency of numbers, this is just to replicate the /sign as a function in APL versus the SQL solution. So sometimes SQL is a lot harder than just regular old APL if you needed to do some data manipulation. Okay. And so that's really all I wanted to share. And if we have any questions, I could take those now. I don't know how much time I have left. Oh, and let me just show, here's the Excel report.
1 minute.
So we generated this Excel. Here's the query results formatted, and actually the whole table. So 600,000 rows generated, driven by APL. Okay. Sorry, Rich, what was that?
Sorry, I was just saying you have a minute, but and you still do. Richard Proctor says my monthly pay is suddenly looking very low.
We never said which currency this is in, so maybe it's in I don't know, yen or ruble, or I don't know. So
I haven't seen any other specific questions.
That's why I did monthly. I figured if I did it the whole yearly salary, that would be a little too much. So I tried to soften the blow. Maybe I should have done weekly.